Welcome back everyone, my name is Dustin. In the last video we started the renderer class and we also created the line batch renderer. I also left you with a small challenge to finish off the simple render functions. I have these two draw line functions. They're hard coded, so we're not going to want to do that. We're going to want to be able to actually call them from the script. So let's work on that today. So this is in our application here. So all I did was add into these two draw. These are all temp, and then I changed the line width to 4. We're going to change that as well. Okay, let's go to our render. So we have all these functions that we have to fill out. First one we're going to do is draw a rect, and this isn't a filled rect. All we're doing here is actually drawing lines. So we just want to make a rect. So we'll just do it like this. We'll do the top line, top, bottom, left, right, top, bottom, left, right. Okay, and we're just going to be drawing lines. So we just go draw a line. I'll copy this a couple times. Draw a line. Draw a line. And draw a line. Okay. So we're going to have a line. And the first line is going to be P1 is equal to rect dot position. P2 is equal to, because we're doing the top one, so the first one is the top left corner, and now we have to do the other side at the top right, okay? So it's P2 is equal to GLM vec2 rect dot position dot x plus rect dot width, and then this is just rect dot position y. That's all we need for that. And oh, we need a color as well. So here, and then color is rect dot color. Cool. Don't worry about line width for now. Right now it's just a global. And we can just copy this line and go to our next draw call. Paste that in there. However, this is going to change a little bit. This is going to be DLM vec2 rect.position.x. Now we want to do it at the bottom. So we need to shift this down by the width. So we're basically, our top corner is going to be our starting point, and we're going to go down from there. Okay, so our top left. So now our bottom will be rect.position.y plus rect.height. And then this one will be the same, but we have to do rect.height as well. Cool. Copy this again. So for the left side, we're basically doing the top corner again, so we can get rid of all of this. And then we want to do the bottom, so we actually want to get rid of this width. And we just want to do the height. Okay, cool. And one more, we're going to do the right. Cool. This is plus rect dot width. And then this is taken out. Cool, just like that. All right, now let's see if that works for us. So this one for draw rect is basically all we're doing is calling draw rect, and we're creating a rect. And dot position is equal to position dot width dot height and dot color. Cool. So let's go in our application, and we have our two draw lines. Let's add a new one in, and we'll say render draw rect, and we'll create a rect. And then our position will be GLM vec2, and we'll put it at 300, 300. Our width, we'll just make it 100, 100, and our color, oh, sorry, we need to do the dot width. dot height. Dot color. And we'll just make this blue. Cool. And it should draw our rect for us. Let's see if it works. Awesome. There's our rect right there. Perfect. So we have our 2 lines, and these are all actually just lines. So they're all going to the line batch renderer. So we got our rects going. Let's go back to our renderer. And let's fill some of this stuff out here. Now, if you're able to do this on your own, good for you. Post that in the comments and let me know about it. If not, that's all right. We're going to go over it now. So the set clear color is pretty straightforward. All it does is take in these 4 values, and it's clamped between the values of 0 and 1. So we can clamp that ourselves or just put a comment saying that the value needs to be between 0 and 1. Okay, so we can just go GL clear color, and then red, green, blue, alpha. Awesome. So basically we can just put a comment here as well. Just say brief. Sets the color buffer to the green when the buffers are cleared. Values are claims 0 to 1. Cool. Then you can put in the params. Params. Paste in GL floats for all colors. RGB. So then when you highlight it, it'll give you a little comment of what it's doing. It'll tell you that it's clamped at a specific value. And I don't like how that's going like that. So let's just add brief here again, and it should put it to the next line. Cool. I like that. So set clear color is done. Then we have clear buffers. All clear buffers is going to be basically just a wrapper around GL clear. And this takes in our bit field mask. So let's look at GL clear. Clears buffers to preset values. So it's a mask or bitwise OR mask to indicate the buffers to be cleared. And a bitwise OR, that means that we're just doing this. We give it our OR value, and now we'll just add it on. It's not like the AND, which will exclude it. So we're just doing a mask. We can go color. If are we clearing the color, then GL color buffer bit 0 or, and we can just copy this a couple times. That's the last one. And then this one will be stencil. We're probably never going to use this one. Stencil buffer. They're all buffers here. This is, we're clearing the buffers. And then this one is the depth buffer. We'll definitely be using this when we start getting into 3D later on, but we're not going to be using it right now. Cool. Okay, so then we have our set blend capability. And if you remember from the last video, the set blend capability is just a wrapper around GL blend func. And we have to have our S factor and our D factor, right? So we just want to static cast to GL enum. Or we can just keep it as a GL enum. Instead of having the, you don't have to do these enums that we created. You can just use the GL enums, but we created these, so we'll use them. And that's the S factor and the D factor. Sorry. And set viewport, that's right. It's just a wrapper around GL viewport. So we basically specify the lower left corner of the viewport rectangle in pixels. The initial value is 0, 0. So this does it opposite to the way that I would do it. So they put the lower or the bottom corner and then the width and the height, okay? And that's fine, but we'll do that as well. So we're just gonna do a wrapper around that. That's just GL viewport, X, Y, width, height. Awesome. All right, are we missing anything? And blend. Actually, I think we are. So in here, let's add a couple more. So void set capability. That's going to be GL capability. And capability. And are we enabling it or not? Bool enable. And then bool is capability enabled. GL capability. Cool. Let's create these functions. So the set capability is just going to be a wrapper around GL enable. So we go if enable. We want to say GL enable static cast GL enum capability. And if not, we're disabling GL disable. All right. And then this one, we're just seeing if the capability itself is enabled. We're not going to use this one very often, but it's good to have it there. So GL is enabled, and that just takes in the capability that we want to test. Awesome. Are we missing any other ones? I think we're good. Got our draw rec. And then there's draw filled rec. But before we get to drawing the filled rec, let's go down here into our clear primitives, and we're just going to clear all of our lines and circles and recs. Is that all we have? Hold on. I think that's all we have. The lines and circles is all we have for now. Actually, let's go back and see. Up here. Nope, we have recs, so we'll clear our recs as well. In our render, clear recs. And eventually we can have sprites and stuff as well. Okay. So drawing recs itself is just basically just drawing the lines. So we don't even really need this draw recs function. We need draw filled recs, but we don't need this draw recs. So we can just get rid of that. So let's get rid of that here as well. And these are all actually going to need the shader and the camera as well. So we might as well put them in this and in this, and then bring them back and do it in the CPP file as well. Get here, grab that. Before we start filling these out, let's actually go and bind our renderer to Lua so we can take these calls out of the application and add them into our Lua script. So that's the goal for today. So let's go into our scripting here and let's add a render binding script here. And we can say renderer bindings.h. And if we look at our sound bindings, we basically want to do the same thing here. Grab all of this, go to our renderer bindings, paste that in. Okay. And we need soul. Include soul.hpp. And here in our scripting, we're going to need to make a struct renderer binding or binder. Renderer binder. I like that. Static void create render ring bind. Soul date. That's a reference taking the Lua. And then we also want our registry. And let's create this bind. All right, so we're actually going to do a lot of binding right now. We're going to bind the lines, the recs, we're going to bind the renderer, and we're also going to bind the camera. So what are we going to need? We're going to need to get our primitives. So we want to go rendering, essentials, primitives. We need that. We need our rendering, or I want the camera. We also want the renderer. I'm also going to need the registry, UCS, not components, sorry. I want the registry. And we might as well throw the logger in here as well. So let's just do the primitives first. So we'll say primitive bind. Primitives bind. Yeah, I like that better. So let's do the line. So Lua, new user type, line. We're going to have to use a namespace here. And then we'll say line, sol, call constructor, sol factories. Const, glm, vec2, reference, p1, p2, and the color, const, color, reference color. All right, return line dot p1 equal to p1 dot p2 p2 dot color equal to color. P1 cool, and that's a line. And we can just copy this whole thing for the rect. Just change our stuff. Rect. Rect. Takes in a position, takes in a width, and takes in the height. Cool. Change these to position, rect, position, rect, width, height, color. We already had color, so we can go back. Let's get rid of this line. Change this to height. Height, width. All right. And then do the circle as well. And now we need to get the renderer. So we need to go auto, reference, renderer. Put a little comment. Find the renderer. So we need to get the renderer from the registry. And it should have the renderer in the registry by now in our context. Get context, std shared pointer of our renderer. Okay, check to see if the renderer is there. If not, renderer. Then we'll just say Scion error. Failed to bind the renderer to Lua. Not in the registry context. return. We don't actually want to bind the renderer itself. We just want the draw calls and different calls. Yeah, we'll just have the draw calls. So we'll just use functions instead. So set functions instead of having the renderer itself to call. Now, you can bind the renderer like we have before, but there's no need. We'll just set all the functions needed. And this one will just be draw rect. Sorry. Draw rect. And that'll be a sole overload. And it takes in the captures a reference, and it's const rect reference rect render draw rect. That's one. And we can copy this. This one will take in our position, our width, const glm vec2 reference position, float width, float height, const color reference color, position, width, height, color. Cool, that's the draw rect function. Now we need to do the draw line function. This one's also going to have an overload. We can just copy both of these and just change this to line. And then the lines have two positions, P1, P2, and then the color. P1, const glm vec2 reference, P2, P1, P2, change this to draw a line. Awesome. So there's our draw rex, our draw line function. All right, it's all caught up there. So we're gonna have to do the draw filled rex and draw circled. But now that you know how to get to it, when we get there, you can do the bindings yourself, okay? So now let's actually bind the camera. Bind the camera. We might as well do it in the renderer bindings. Okay, so we can go Lua, not Lao, Lua dot new user type camera 2D. And we're just going to call this the camera. So no constructor. Because we're already going to have a constructor, okay? Speaking of which, we forgot to get the camera. So auto camera is equal to registry dot get context std shared pointer camera 2D. Check to see if we have our camera. If not, camera. Put an error. Failed to get the camera from the registry context. Failed to bind the camera Lua. Awesome. So we have our camera, we don't want a constructor, but we will have a get so we can get an instance of it. And then let's do the position. We need to do a little lambda here. Return camera, get position. Is that what we called it? Let's open up our camera real quick to make sure that so we have get position, get scale, set position, set scale. Cool. Eventually we need to be able to get world chords, screen chords, and those things like that. Okay, so we'll go back into our render bindings. So get position, then we want set position. Let's go to our camera. What is it for set? Yeah, it's just vec2. That should probably be const. So let's go back into our render. New position. Scale. And set scale. And I believe scale is just a float. All right, so that's pretty good for now. We have a lot of other functionality we need to add later, and we'll do that later, but for now, this should be good, okay? So now we actually have to go and call this render bind in our scripting system. So let's go do that. So here in our systems, scripting system.cpp. Now we have our sound bindings. Now let's include our render bindings. All right, and then down here, our sound binder, we want to do the same thing. So Scion4, scripting, render binder, create render bind, Lua, registry. Awesome. So now everything should work. Let's see if it builds. Awesome. So we built, but these are still hard coded in the application. So let's take these out of here and put them into Lua. Okay. So what I would like to do is go to our application.cpp and let's actually just take all of this out. Okay. Get rid of this comment. We'll leave the line width for now. Let's open up our main.lua. Main.lua. And in here, yeah, we can just do it right here. We put all this in here and we have to make some subtle changes, okay, because we don't need the renderer like this. We don't need this. We do need line, keep line. And we don't need the GLM stuff. We don't need these. These need to be regular parentheses. Don't need the F. I believe we have a color binding. If we're not, we're gonna have to go do that. Cool. Cool. So we need to do the same thing for this one, but we can just copy this line. Just change the numbers. 200. 250, 50, 200, 0, 255, 0, 255. Cool. that's that one. And now we have to do our rect. All right, we're probably going to have some errors, but let's see what happened. And build. And we got some errors, and that's fine. Okay, so 12 mains at 12 here. Ah, copy and paste problems. Try again. Awesome. So it didn't draw a rect there, it only drew the one line, and that's fine. Okay, so draw a rect, that takes in a rect. Let's go see. Render bindings, draw a rect. Draw a rect, takes in a rect. That should work. Draw a rect. Let's run it again. So it only has our one line. These two lines worked. Why is my rect not running? That's fine. Right here. That would have been hard to see. All right. There we go. There's our lines. There's our rect. Okay, cool. All right, so we're drawing rects and we're doing everything from Lua. Everything's been removed from the application. It's all being done in our main.lua. Now, there's something else that we can do. If we go back to our render.cpp, we have our draw a filled rect. Now, there's two things we can do. We can use the batch render that we already have because it will draw a rect for us right now. A sprite is nothing but a quad or a rect anyway. So you can use this and just add a new function in if you like. For instead of add sprite, you can have one called add rect and just draw the rect instead. And all you'd have to do is just not give it any texture value. So if it has no texture value, no texture ID, it'll just draw the color that you send in with it. Or you can create a new render and just call it rect batch render or quad batch render and set your, when you go to initialize, you don't have to do the UVs. You would only need the color and the position. And then you can use that color shader that we created previously. Okay? So give that a shot, try that yourself, and think about any other functionality that you might need. We do have here in the application, we're doing the line width here. Well, we can do a wrapper for that as well. So do a wrapper for the line width and any other render stuff that we might need. So in the next video, we'll do the draw filled rect, and we'll do it both ways. We'll do it in a sprite batch, and we'll also create our own little rect batch renderer. And we'll also get into drawing the circles and that stuff as well, okay? So that's good for now. We have bound a lot of the functions that we need. And you can actually do bindings for these as well, where you can set these capabilities from the Lua scripts. So say you have a settings file and you don't want to have to go into the engine to make changes. You can just do it in a settings file where you're changing these capabilities in there, okay? So you're changing set the window height and all these things. You can do all those different bindings if you like. And we'll get into that later as we go on, okay? If you have any questions or concerns, please leave them in the comment below and I'll make sure to get back to you. Okay, take it easy.